Hi, and welcome to this course, Fundamentals of Electrical Circuits. First, let's go over with the coverage of this course by reviewing the contents of this syllabus. You can download this syllabus from your Blackboard by going to Course Information and clicking and downloading this syllabus. Okay, now this course is actually made up of two main topics. We have the DC circuit analysis and the AC circuit analysis. In some programs, um, these two main topics are actually covered by two separate courses. We have the DC circuit analysis and the AC circuit analysis. But under this course, we will be compressing those two uh, courses under one course. So in first week, um, we'll be discussing the basics of electric circuit. So we'll be looking at what is an electric circuit, what are the elements in an electric circuit, and the variables that makes an electric circuit, or the variables that are involved in an electrical circuit. For example, voltage and current. And under the same week, we'll also start discussing resistive circuits. So these are circuits that involves only resistive elements like the resistors and of course the sources that drives these resistive elements. Under this week we'll also cover series and parallel circuits and the combination of them, the series parallel combination. We'll also teach you the basics of voltage divider and current divider, how to use them, and also the concept of Ohm's law. We'll also cover power. How do we deal with power in resistive circuits? Then on the second week, we'll start on the fundamentals of circuit analysis. So we'll cover their Kirchhoff's laws, the voltage and current laws of Kirchhoff's, and also the techniques in dealing with circuits, the nodal and the mesh analysis. On the third week, we'll be covering network theorems. So these are additional tools in dealing with circuits. So popular theorems like Thevenin's theorem and the Norton's will be covered there. And this will continue up to the fourth week. And before this week will be over, we'll conduct our preliminary course assessment. Now, in the fifth week, we'll be dealing with circuits that involves uh, elements that stores electrical energy, like the capacitors and the inductors. So the inclusion of these elements uh, alters the behavior of electric circuits, where now we will be dealing with what we call the transient behavior of these circuits. So we will cover RL, RC, and RLC circuits under this week. And that will continue up to the sixth week, And on that same week, we'll also start with the topic on AC circuits. So this will start with sinusoids. So these are sources, voltage or current sources that are not constant but actually varying sinusoidally. So concepts like uh, leading and lagging in a sinusoidal waveform will be covered under this week. Now on the week 7, under week 7 will be uh, now introducing you with concepts on how to analyze AC circuits. Uh, uh, it is not really something new, but uh, uh, we could also use the concepts that you have learned in DC circuits in AC circuit analysis. So like Kirchhoff laws and nodal and mesh analysis. So the same concept that you have learned in DC analysis will be also applied in AC analysis. And on the eighth week, we'll be conducting our midterm course assessment. Now, on the ninth week, we'll be covering AC power. So, how do we deal with AC power in AC circuits? So, the way that we deal with power in AC is slightly different how we deal with DC. There are several aspects in AC that needs to be covered, like average power, reactive power, and complex power. Then on the 10th week, we'll also cover uh, three-phase systems. So these are still this is still under AC circuits, but now we're dealing with three-phase systems. So the first part of AC will cover single-phase systems, and the second part will cover three-phase systems. The analysis is very similar with the single phase AC analysis, but we'll be um, covering or discussing additional techniques in dealing with three phase systems. And on the 11th week, we'll be uh, discussing the one of the most important equipment or device in an electrical system or circuit, and that is the transformer. And finally, on our 12th week, we'll be covering our or we'll be conducting our final course assessment. Now, on the textbook, we recommend the use of Engineering Circuit Analysis by McGrew-Hill. Um, the author is William Haidt and Jack Kemerly. So you can actually download an e-copy of this um, textbook. Uh, we'll also be using an online tool from McGrew-Hill where we can uh, open the ebook and also use an online tool called Smartbook that can help you in your study of electrical circuits. Now, there are other books, popular books, and they are listed here. And I also recommend the book Fundamentals of Electric Circuits by Alexander and Sadiku. So this one can be also be found in the internet. So for the course requirement, this will be the breakdown of our grades, of your grades. So 60% for the major assessments. For the quiz, it will cover 25%. seat work and homework 10%, and class participation will be 5%. Okay, so as usual, the basic policies of the school will be applied in terms of particular in terms of your attendance. And for the intervention, I will be posting my schedule as well, so that you will know my schedule. And in case you need intervention, you can go to me, visit me, and we can talk over. We can talk over the issues that affects your class standing. So I think that's about it for the introduction. And so for our next video, we'll be discussing the fundamentals of electric circuits. So I'll see you on the next video.